Hello, my name is Vadim Orlov. I'm a CTO and co-founder of DataForge. Today, I'm excited to introduce you a new DataForge product feature called Subsources. It will massively simplify working with complex data structures. And if you haven't already, please read my short blog. I included the link into the description. It will really help you understand the context and the complexity of the problem. With that, let's get started with data structure. The data set that I would like to use for this demo is orders in the online store. It's structured as a JSON lines text document where each line represents JSON object representing the order of the customer. So let me format this so you can see this a little bit better. Each order has top-level JSON keys, which are represented by simple data types like strings and numbers and dates. And those represent the order header details. So things like customer ID, due date, credit card ID, etc. And then we have order detail nested array of JSONs, which represent products being ordered by customer. So each of those has different structure and it has attributes like quantity, product name, price, etc. And each of those detail lines also have a nested array of tags which contain product attributes stored as a name value pairs, things like color and weights, etc. So this structure is fairly common if you ever worked with APIs, REST API, you return this structure when you do the GET request. It's also being used in the event hubs, in the events payloads, also in the NoSQL databases. So fairly common structure to work with and not trivial, obviously, because you have 3 levels of nesting here. To represent this in a kind of ERD format, this is what it looks like. So you have orders as kind of top-level table. You have order detail and then tags. And they are connected with one-to-many relations, as I illustrated here. And the common approach, as I described in my blog, is to actually normalize this data first before you transform this and store it as 3 tables. So I'm going to show you alternative approach and how we, with DataForge, we massively simplify this. So you basically don't need to normalize this and you can work with those 3 data sets and transform them individually without going through complexity of normalization. I saved the file in the S3 bucket, and now I'm going to ingest this into the DataForge and show you how easy it is to add transformations for the data contained in those nested complex arrays. So let's create a source first. We'll call it orders. And then we'll pull it from the file using this connection, which I pre-configured already that points to this bucket. Then we'll pull it from orders JSON. The file type is JSON, and that's all we need to specify here. Click Save, click Pull Now, and DataForge should start pulling this file. While it's processing, I'm going to jump quickly to the ERD and show you the transformation that I'll create for this example. So in the order detail, we have 2 columns, quantity and price. I'm going to add a new column called line total here. So this will be column, it's quantity multiplied by price. It will be stored here in the subsource. And then we'll calculate the sum and put it here on the orders. So this will be the sum of LT, excuse my handwriting, and it will be calculated as an aggregate of this new column that we added. Okay, so back to the DataForge, so you can see the source has been loaded already, so we can check the data in the data viewer. Here you can see all the columns. This is the column that contains the order detail. You can see that this is the complex nested array of data. Let's look at this in the Databricks. You can look into this here, and this is what it looks like. So this is the array here. If I expand this, you can see that it contains product details for each line of the order. So product name, product ID, etc. Okay. So let's go back here. Go to the rule, and then I'm going to create a rule here. Let's call it details. And we will use order detail column for this. And this is a new rule type we added. It's called subsource here. And we save. Once I made the rule, it immediately opened the new tab with a new source that it created, orders details. And this is a specific type of the source. We call it subsource. You can see several tabs are disabled. This is because all the data processing is actually happening in the context of the parent source, which is orders. And you can see the parent source rule which we created is accessible through this link. But what I'm going to do here is I'm going to create a rule and calculate that line total which I was just showing you. So let's go create a rule. We'll call it line total. And the calculation is price multiplied by quantity. Validating expression, decimal, save, done. Okay. Now, if I look at the relations diagram here, you can see that our system automatically created the relation to the parent source. So this is a parent source, orders. This is the source I'm in now. This is a new relation type called implicit, so it doesn't require relation condition. It's automatic by virtue of this array of elements containing in the column of the parent source. And now, because of that relation, we can create calculations on both sides, on orders and order details, using the attributes from the related source. So let's create the new column here. Let's call it the line total sum. And for the calculation, we're going to pull order details source here. And I'm going to find this line total rule which I just created. And you can see it tells me you must use aggregation because the cardinality is many. So I need to use aggregate sum in this case. Okay, and now everything is good. I can save this. And now I can go back to inputs here and just click recalculate. And this will apply this will basically calculate both rules and save them in the data. So once it's done, should take a few seconds, we can go back to the table and I'll show you how these rules materialized in the table. So it's running, okay, it's done. Let's jump to the Databricks and refresh the data in the table. And I'll show you really quick where we store the actual data for that subsource we created. So this is our original column. So if we expand this, you'll see the nested array of elements. And this is the column which we created for this subsource rule. So this is details column, if you recall. And if we expand this, you'll see that it contains all the same elements in that array from a source column, but we added the line total column here, which is calculated from price multiplied by quantity here. Okay. And then if we scroll to the right, you see that there is a new column in the orders table, which is an aggregate of the sum of this line total sums. So looks like this. As you can see, I literally did it with like 2 clicks and 1 recalculate. And now you have you basically calculated 2 attributes and then summarize them in the parent source. So really powerful tool to use when gives you ability to do many different transformations without actually having to go through this normalization process manually. Now let's jump into the lineage so I can show you a better view of the data flows. So I'm going to create new lineage graph and then add the details subsource into it, and we'll add all the regions for that. Okay, and then just organize this a little bit better. Okay, so let's go from the bottom. So this is our orders. This is our source. That's essentially the file I was showing you at the beginning. The order detail is the nested complex array column. So that's here. So from there, we take the data and explode it into the raw attributes. So you can see like product name, product ID, this match the JSON keys that I was showing you in the nested array. Okay. Then we use 2 of those to calculate the new key, call it line total. That's also stored in this subsource. Okay. And then finally, we take this sum of that line total, and that flows into the parent orders source. Okay, so that's and explains how this is all processed. Physically, though, the data that is contained in this orders details subsource is stored in the in this new column which we added to the orders. Okay, that's what I was showing you earlier in the Databricks view. So if we jump back to Databricks, this is a column. So details, line total, you can see all the same raw attributes, and then the new column here. Now let's take it one step further and pull a couple of elements from this tags array. So if you recall, we have a second level of nesting inside that nested array. And this is essentially key value pairs representing the attributes of the product. So let's pull a couple of them, like color and weight, into the order detail so we can use them for transformations. So and we can do this same way as pretty much as we did with the first subsource. So I'm gonna open that subsource which we created, and I create a rule here. Find the tags array, okay, and this will be a nested subsource. So subsource within the subsource, okay, and we'll call it, just call it tags subsource. Okay, save it. I'm not going to create any rules here, but you can see like now we have this new source created, and if we look at the diagram of the relations, this, you see it created those 2 relations. So it's basically now we have 3 orders sources: orders top level, orders detail, and orders detail tags with implicit one-to-many relations. So essentially it's the same diagram I was showing you here, except it's virtual, right? Like all of this, only one data table really exists here. Those 2 are virtual, so they exist as a column in this top level table. So now I'm gonna pull, like I said, the couple of tags from that source. So let's go back to order detail here, and then I'm going to create a new rule. Now that I create the subsource, I can, this is available for rule creation here. I'm gonna say, okay, give me the name that's weight, and just simple case statement. So if name is weight, then give me the value. And again, because it's one-to-many, we need to aggregate this. So for this, I'm going to use first function, first not null. So this function will return value, first value which is not null, and also I'm going to confirm convert it to decimal because it's weight. Also may want to aggregate this. We'll save that. So I'm going to copy this. Save, then create a similar rule. Let's rename it to weight. Create similar rule, call it a color. So all we need to change here is color. Save. Okay, so now we have two extra columns created in the subsource, weight and color, and I'm going to add one more rule in the parent source here. I want to calculate sum of the weights. So for shipping, let's say we want to calculate the total weight of the order. So I'm going to call it total weight, and we're going to pull it from order details, weight, and now we just need to aggregate it as a sum. Okay, save, we calculate. While it's running, I'll just quickly show you here what we did. So we pulled one of the tags, so two tags, name, named weight, and added it as an attribute here. So now we have weight here. Again, apologies for my handwriting. And then second one is color. And then finally we added the sum of weight here into this table, so it will go here. Okay. Right. So let's jump back into the. So it's already calculated. So now we can go to Databricks again and look at the data. Let's refresh the table. So details, we expand. You see two new attributes now. We have color and we have weight, and those were pulled from this tags nested array. And we also have a new column called total weight, and you can see it's calculated as a sum of weights right here. The last thing I wanted to show is how to create an output. So yes, Subsources also support outputs. So while we store the data as nested arrays, sometimes you actually want to look at this data in the exploded/unnested way for reporting or for other purposes, and outputs support that. So if we go, let's go create a new output. Call it order details, and we'll make it a delta for simplicity. So we'll write into the delta table, call it details, and then we use the same schema. Save. Now I'm just going to map the subsource into that table and add all the columns here. And I'm going to add one more column just to show you how we can reference columns from the parent source. So I'll create column order ID, and now I'm going to map it to the attribute from the parent source. So I'm going to say so orders sales order ID, save, okay, and then I'm going to reset the output. Okay. And let's go to Databricks again and query that table. So let's wait, make sure it's finished processing. It should be pretty quick here. Okay, it's done. This is our orders table, and let's query the order details table which we just made. So we'll put them side by side so you can see the difference. Okay, so as you can see here, this table is at a different grain, right? This is at the grain of order detail. Let me illustrate this by showing you this column which we added. So this is order ID column, and you can see for each order ID we have multiple rows, and each row being individual line item in the order. Yeah, so essentially that created like a nest/explode view of the table with individual columns of the JSON, which I was showing you earlier, and all the attributes which we added, like color and weight, is here somewhere. Yep, right here. They are now part of the table, so it gives you ability to generate outputs and send them to your final destination at the new grain of data exploded for kind of final consumption. Hope this was helpful. Please send me your comments and feedback. I definitely appreciate that. And then yeah, go and check our website, and we have a free trial available for 30 days. This feature is coming out very soon in release 8.1, along with many other great improvements and upgrades, including streaming and many others. So yeah, check it out, and thanks for watching, and I'll see you soon.